Hello and welcome back. This is a video over 8.3 notes, and this is about solving multi-step equations. So, we're going to have to do some more advanced solving of equations, using some algebra techniques. So, what I want to do is go back through a one-step equation, and we've done a couple of them. So let me just write up a couple of examples here. The first example is, let's think of an equation like x plus 7 is equal to 10. Okay, remember you have this variable x. Okay, we don't know what that is. Okay, it's just some number. And we have this equation. We say that if we take some number and we add 7, that's going to give us 10. Okay, and so we want to figure out what that number is. And we can intuitively think about it. And we can say, all right, well, what number would I add to 7 to get 10? And that number would be 3, okay? But let's go through what we would need to do to solve this algebraically. So if I have some variable plus 7, the objective is to get this variable by itself and move this 7 to the other side of the equation, okay? So what I want to do is this. I always do the opposite, okay? So if I'm adding 7, then to move it to the other side, I'd want to subtract 7 from both sides. Okay, and so we do 7 minus 7, that cancels out to 0, and then we get x is left, okay? And then we have to do the math here, and we say, okay, well, what's 10 minus 7? And that's going to give us 3, okay? Okay, and what we can do is we can actually check our solutions by plugging 3 back into the original equation, okay? So if I wrote it as 3 plus 7 is equal to 10. If I do 3 plus 7, that's going to give me 10 on this left side, and then I get 10 on the right side, and that's a true statement. Okay, so let's look at another one real quick, and let's write up an example, and let's think of like x minus, let's not use x, let's use like t minus 4 is equal to, say, 6, okay? And so you think about it, t is an unknown number. We're trying to figure out what it is. And we take that number, we subtract 4, and that gives us 6, okay? And so we want to know what number is that if we subtract 4, we'll get 6. And that number is going to be 10. But to do it algebraically, we want to do this. We want to do the opposite of subtracting 4, so we want to add 4 to both sides. And then we're going to get that t is equal to, and so this cancels out, 6 plus 4 is 10, okay, and that's our answer. All right, let's take a look at another one real quick. And both of those are using addition and subtraction to solve equations, but let's use multiplication and division. So let's say we have an example like, 2x is equal to, say, 12, okay? And what this reads is that it's really 2 times x is equal to 12, okay? And so you think about it, okay, 2 times some number x gives me 12. What's the number? Okay, and the number would be 6, all right? But let's go ahead and do that algebraically, and let's, if we're multiplying by 2, the opposite of multiplying by 2 is dividing both sides by 2, okay? 2 divides out to 1, okay, 1 over 1, and 1 times x is just going to give us x, okay? And then I have 12 divided by 2, which is going to give us 6, all right? And so that's how we do something like that. The last one we'd want to do is, something like this. Let's think of an example where we have, like, say, let's do r divided by, say, 3 gives us 7, okay? And so what we think about is some number, r, divided by 3 is going to give us 7. What's that number? Okay, and so if we think about it, that number is going to be 21. But let's do it algebraically. All right, so, this notation here indicates that we're dividing by 3. So the opposite of dividing by 3 is going to be multiplying by 3 on both sides, okay? And when I multiply by 3 over here on the left, it's going to be really 3 over 1, okay? And the 3's are going to divide out to 1, all right? And so then we're left with r, and we do 7 times 3, which gives us 21. And so r is 21, All right, so these are just one-step equations where we have to just do one step to figure out what the variable is. All right, so what I want to do is look at something that we call a two-step equation, where we have, some number times 3, and then we add 4 is equal to 13. And we want to solve for x. And so what I want to do on this one is, think about, we want to get x on one side of the equation. And so we want to move the 4 and the 3 over to do that. Now what I want to do first is I want to move this 4. Okay, we always kind of leave the number that's next to the variable for the last step. And so the first step I want to do is actually subtract this 4 from both sides. So I'm going to go ahead and do that. And, all right, draw my line. And then the 4's add to 0. Okay, and so then you're left with on the left side 3x. And that's equal to, okay, 13 minus 4 is going to give us 9. All right, so now I have the equation 3 times some number gives us 9. Okay, and so if I want it, now I have a one-step equation. We're back to like a one-step. So now what I have is I want to divide both sides by 3. Okay, and then I get that x is equal to 3. Okay, and that's my solution for this equation. Okay, and we could even check, all right, we'll check this one. But what this means, I'm going to do 3 times 3 plus 4. Is that equal to 13? Okay, and so if I do my order of operations, do my multiplication first. 3 times 3 gives us 9, and then add 4, and then that's going to give us 13. Okay, so then 9 plus 4 does give us 13, and that's equal to 13, and that's a true statement, and so this is my solution. Okay, now I want you to notice something. How, when I did this problem, I did order of operations. I did the multiplication first, and then added 4 to get 13. All right. When you're solving equations, you kind of go in the opposite. Okay, where I'm going to do addition and subtraction first, and then divide. Okay, and that's kind of how we have to think about it. All right, let's go ahead and go back over here. And this says -5 times some number x, and then we subtract 6 is going to give us a value of 16, okay, positive 16. So what I want to do is just manipulate this and move the -6 and the -5 over to this side of the equation and leave my x. All right, so if we're subtracting 6, I want to do this part first. I'm going to add 6 to both sides. Okay, do the opposite of subtracting 6. All right, and so then if I have -6 plus 6, then those are going to add to 0, okay, and cancel out. Therefore, on the left side, we're equal to, we've got -5x on the left, all right, and then that's equal to 16 plus 6, which is going to give us 22. Okay, now here's the weird part. All right, we're still doing the same thing. Okay, we're still going to divide. We're multiplying by -5. So the opposite of multiplying by -5 is dividing by -5 on both sides. And so these are going to divide out to 1. And so then x is going to equal -22 fifths. And that's my answer. Okay, and we can check that answer to see if we're right. But as long as you're doing the steps right, you should be able to get the right answer. So I'm not going to check this for time purposes, but I would encourage you to do that. That's a way to make sure that you have the right answer, okay? And then if you don't get it right, go back and try something else and try something different, okay? All right, the next section is about combining like terms. So we have to do this concept of combining like terms before, a lot of times when we're solving equations, okay? And to think about what like terms are, like terms have the same variable, okay? So the same variable with the same exponent, all right? And so in this case, we don't have to really, for the problems that we're doing today, we don't have to really worry about what the same exponent is. But we'll kind of revisit this in the past, or in the future. I mean, we'll take a look at that and see, how that affects things. But let's go ahead and solve this equation. Now, what it says here is that I have 3 times some number x plus 4 times some number x is equal to -14. We want to figure out what this variable is here. Now, because these have the same variable, and I like to underline my like terms, okay? Because they have the same variable, what I can do is I can combine these, all right? And one way to think about it is this. Let me rewrite this problem down here. I've got 3x plus 4x is equal to negative 14, okay? And really, when you have 3 times x, what you're doing is you're adding x 3 times. And so you have x plus x plus x, okay? That's 3x. If you have 4x, that means you're adding x 4 times. And so you're doing plus x plus x plus x plus x, 1, 2, 3, 4, and that's equal to negative 14. Now, the question is, how many times total are you adding x? And you get 1, 2, 3, 4, 5, 6, 7. Okay, and so you're adding x 7 times. And so you get 7x here, and that's equal to negative 14. Okay, and we can solve from there. We would divide both sides by 7 on the left and on the right, and then we're going to get that x is equal to negative 2. All right, so there's that. Okay, but I don't want to do this every time. I don't want to write out 3x and 4x. But what you may have noticed was that if you just take 3 and 4, you get 7. And then you just keep the x. And that's how I do combining like terms, okay? If they have the same variable, raised to the same power, in this case it'd be 1, okay? That's the exponent above the x, but don't worry about that right now. Then I just add my coefficients. And my coefficient is the number in front of the variable. Okay, so I would just take 3 and 4, add them together to get 7, and then just keep the x, all right? So that's what I'm going to do here, okay? And I'm just going to get, do that in my head. 3x plus 4x gives me how many x? That's 7x, okay? And that's going to equal negative 14. If we divide by 7 on both sides, then we're going to get that x is equal to negative 2. Okay, so we got the same answer as we did before, all right? Down here. All right, so let's take a look at another one, okay? This one's a little bit interesting because what I see here is that I have my equal sign, okay, and I have variables on both sides of that equal sign, okay? And what I want to do is I want to get all my variables that contain an x on the left side, okay, and then get all the numbers on the right. All right, so let's do this. Let's get our variables on one side. Now I've got a 2x here and a negative 3x here, okay? Now you can move either the 2x or the negative 3x. It really doesn't matter. However, there becomes this time when it's important to kind of think about your algebra and think about what way's the easiest. Now, a lot of people don't really like dealing with negative numbers, okay? I'm fine with it. That's because I've been doing this for 20 years. But what I've noticed is that like if I move this negative 3 over to the other side, that means that I would add this number, okay? Doing the opposite of subtracting 3x, if I added it, I would move it over here. And so if I add 2x and 3x, it's going to be a positive number, okay? So let's do that. All right, let's go ahead and add 3x to both sides, okay? And then what happens here on this right side is, I can take negative 3x plus 3x, add those together, okay, and combine these like terms. And what I notice is that, same thing as we did before. They both contain an x, so this math is a little bit interesting and new, but I can add these together, and I just take negative 3 plus 3, and that's going to give me 0x, okay? 0 times x. All right, so keep that number and do the math, negative 3 plus 3, but then keep the variable, all right? And then let's just copy everything else down. We've got a plus 3 over here, we have a negative 2 here, but then we have to add these together, okay? And if I do 2x plus 3x, how many x do I have? And 2 plus 3 is going to give me 5. So I'm going to write down 5, keep the x, and that's my next step, okay? Now the cool thing is that right here, 0 times x, that's just, 0 times any number is going to be 0, okay? So this just becomes 0, and I don't even need to put it anymore. And I'm just going to rewrite my equation, 5x minus 2 is equal to positive 3. Okay, don't need to put the plus there. All right, so now I have a two-step equation. All right, and so now I'm just going to subtract the 2 from both sides. I'm sorry, I'm already subtracting 2. I want to do the opposite of subtracting 2, which is add 2 to both sides. And the negative 2 plus 2 adds to 0. Okay, and then we get 5x left over, and that's equal to positive 5. All right, and then I divide by 5, and then divide by 5. These 5's divide out to 1, and I'm just left with x. And then 5 divided by 5, that's just 1. Okay, and that's my answer. All right, so sometimes they're pretty simple, and you should get like nice, easy numbers, but it just kind of depends. All right, so let's take a look at the next one. And the next one involves an extra step. Okay, so what I'm doing on this one, okay, I'm not gonna, okay, let's just think about it. You have this part here on the left side of your equation, okay, left side of the equal sign. And then you have this part over here on the right side. Now, what I want to do first is think, okay, is there anything I can do, any things I could combine on this left side of the equal sign? Because I notice that I have two x's here, and then on the other side of the equal sign I have this x, okay? So what I want to do first is just combine the 6x and the negative 7x. Okay, so if I do 6 minus 7, that's going to give me negative 1x. Okay, this is negative 1x. Okay, negative 1 times x. Okay, I'm going to keep the, positive 5 here, okay, because that's what's left over on this side of the equal sign. I'm going to write my equal sign. Okay, and then let's look on the right side. And the right side, I notice I have a 10 over here and a 3. Those two numbers I could also combine, okay? So I'm going to do that. So I'm going to take the 10 and add the 3 to it, and that's going to give me 13, okay? And then I have a minus 4x. Didn't do anything with that, okay? Now what I want to do is I want to get all my x's on one side of the equal sign, and if I add the 1x here to this right side, this will give me a negative number, okay? So what I want to do is actually add the 4x to both sides, because that will make my coefficient positive. So if I do add 4x to both sides, add 4x, okay, then negative 4x plus 4x adds to 0, okay, and then negative 1x plus 4x, so 4 minus 1 is going to give me positive 3x. Okay, and then I'm going to add 5 to that, and that's going to give me positive 13. Okay, and so then I have a two-step equation. Okay, so I'm adding 5 here. I want to do the opposite of adding 5, and that's going to be subtract 5 from both sides. Okay, and then 5 plus negative 5 is going to add to 0. And we get 3x is equal to 13 minus 5 is going to give us 8. Okay, and so then what I'd want to do is I'm multiplying 3 by x, so I'm going to divide by 3 and divide by 3. 8 doesn't go into 3 evenly, so we just write our solution as x is equal to 8/3. And that's it. Okay, so all these problems, kind of got a little bit more difficult as they went on, okay? What I noticed was, these problems up here just took one step, all right? These problems here took 2 steps. Some of these took 3 or more steps, okay? This problem got a little tricky, and that's just because you're adding in a lot of different things that you have to do. Okay, but you just want to get it down to where you have a 1-step equation or a 2-step equation and solve from there. So if you just follow, these rules, and guys, remember, when I'm going through this, especially on like these new things that you've probably done before, haven't done it in a long time, and maybe you really struggled with it, the thing that you need to realize is, I'm doing all these steps, and as I'm saying them, I'm writing things down. So it's important that you may want to go back through this video and write down things that I'm saying, and like write down the steps. Like, what am I doing from this step to this step and this step to this step? All right, and that's what you need to ask yourself when you're doing these, okay? All right, let's move on. Let's talk about something called clearing fractions and decimals. So what I see here is I see a whole bunch of just random gibberish, okay? I see 2/3 x minus 1/6 plus 1/2 x is equal to 7/6 plus 2x. And we want to solve for x. Yuck. Okay? And there are ways of doing this. We could get a common denominator, but something that we could do is we could clear the fractions. Okay? And I'm going to show you what I mean by that. What I want to find here is I want to find a common denominator. Let me write that here. Okay, we want to find a common denominator. Okay, and so our common denominator here in this one would be 6. Okay, 3 times 2 gives me 6, and 2 times 3 gives me 6. So what I want to do is I want to multiply the entire equation by 6, okay? Multiply by the common denominator. And when I do that, I'm going to do it to every single one of these terms, okay? To this term, to this term, this term, this term, and this term, okay? So watch what I do. All right, so I'm going to do 6, and instead of just writing 6, I'm going to do 6 over 1 because we're dealing with fractions, times 2 over 3x minus 6 over 1 times 1/6 plus 6 over 1 times 1/2 times x, and that's equal to 7 over 6 times 6 over 1 plus 6 over 1 times 2x, okay? And we'll put this over 1, doesn't really matter. Okay, so now what I can do is I can multiply these fractions together, okay? And 6 times 2 is going to give me 12. 3 times 1 is 3, so 12 over 3 times x. 6 over, so minus then, 6 times 1 is 6 over 6 times, that's just there, hold on, let me erase that, times, whoops. Okay, sorry. Okay, let's do 6 over 6 plus, okay, and then I've got 6 times 1 over, 6 times 1 is 6, 1 times 2 is 2 times x, and this is equal to 7 times 6, which is 42 over 6, and then plus, this is going to be 12x. Okay, so now what I want to do, and the reason why I multiplied all those by 6 is because all of these are going to divide into something else. Okay, so 12 divided by 3 is going to give me 4 times x, minus 6 over 6, which is 1. Okay, 6 divided by 6 is 1, plus 6 divided by 2, which is 3 times x, and then that's equal to 42 over 6, which is 7, and then plus 12x. All right, and so now what we have is we have kind of this long equation that we can now solve by combining like terms. Okay, so watch what I do. I've got 4x and 3x. If I combine those as like terms, okay, on this side, and I don't have to do anything on the opposite because we're still just talking about the one side of the equal sign, okay? So if I add 4x and 3x, it's going to give me a total of 7x. Okay, minus 1 is equal to 7 plus 12x. Okay, now what I want to do is I'm going to move this 7x to the right side of my equal sign. Okay, I could subtract 12 if I wanted to, doesn't matter, but you know, I'm going to make things easy because if I take 12 if I subtract 7 from 12, it'll leave me with a positive number. Okay, and so let's go ahead and subtract 7x from both sides, minus 7x. And then that's going to give me, those are add to 0 and cancel out. I've got negative 1 is equal to 7. And then 12x minus 7x is going to give me positive 5x. Okay. And so, okay, so from here, you know, I've put the x on the right side of the equal sign, and that's okay. Okay, I don't have to always keep it on the left side. I can kind of do whatever I want. But here I'm going to subtract 7 from both sides, okay? And positive 7 minus 7, that adds to 0. So then negative 1 plus negative 7 gives me negative 8. and that's going to equal 5x. Okay, and then what I want to do is I'm going to divide both sides by 5, okay, here and here, and so then x is going to equal negative 8/5, and that's my answer. So this is a very long, drawn-out process, but it's much easier to clear the fractions first by multiplying by a common denominator and then solving from there, as opposed to trying to get a common denominator here and solving that way. You can still do it that way. I can show you that if you want me to, but I would prefer if you guys cleared the fractions first. Okay, and then we have this other idea of clearing decimals. Okay, and we want to multiply, depending on the number of decimal places that these have, tells me what I want to multiply this by. Okay, so what I want to do is look at the decimals and think about my max decimal. So my decimal is 2 places, okay, and that occurs right here, okay, and so that tips me off and tells me what I need to multiply this by. So if my decimal is 2 places, which is your hundredths place, then that means I want to multiply by 100, okay? And the reason is because I have 2 zeros, all right? And when I do that, okay, if I multiply all of this by 100, everything in here by 100, I'm going to take 100 times 16.3, okay, minus 100 times 7.2y, and that's going to equal 100 times negative 8.18. Okay, and when I do that, what this is going to do is this is going to move the decimal place 2 units to the right. Okay, and so if I move that to the right 2 places, this is going to give me 1,630 minus 720, so minus 720, and then this is going to equal negative 818, so negative 818. All right, so then what I have is I just have a 2-step equation. Oh, I need my y here, multiply by y. Whoops. All right, and so what I want to do at this point is I'm going to solve this equation for y. All right, and I want to move this 1630 over, and I kind of, I can do a number of things here, but it kind of just depends on like what you want to do. I always operate with y last if I can, okay, given a 2-step equation like this. So what I'm going to do is I'm going to subtract each side by 1,630, okay, minus 1,630. These are going to cancel out and add to 0, all right? So I'm left over with negative 720y is equal to 818 minus 1630. And this is going to give me a value of negative 2,448. Now, the next thing I want to do is I want to divide both sides by negative 720. Okay, divide by negative 720. So if I divide this by 720, okay, it's actually going to give me that y is equal to, and a negative divided by a negative is going to give me a positive. So I get a positive value of 3.4. Okay, and I just put that in decimal notation. Okay, and the reason why I'm putting it in decimal notation is because our original equation is written with decimals. Okay, so if your equation is written in decimals, decimal answer is fine. If your equation is written in fractions, that's fine too. Guys, this is a lot of stuff. We got one more page of notes for this, and then we'll be done. All right, thanks. Okay, the next thing I want to do is use what's called the distributive property. And this involves equations that have parentheses. So what this means when I read this is I say 8 times some number is equal to 2 times the quantity, 12 minus 2x, okay, that number, okay? And so what I want to do here is use what's called the distributive property. And when I do this, 8x equals 2 times the quantity. When I have that quantity, this number that's out here that's being multiplied, I want to do this thing where I just make these little arc marks, okay? And what that means is I'm going to take this 2 and multiply it by everything on the inside, okay? So I'm going to take 2 times 12 and then minus 2 times 2x, okay? And 8x is over here on the left side, okay? And so when I do this, let's go ahead and rewrite our equation. 8x is equal to, and let's do the math. 2 times 12 is going to give me 24, okay? Minus 2 times 2x, okay? And when I have that, I just multiply my numbers together, so I'm going to get minus 4x and just keep my x. Okay, now I have to combine my like terms. I'm going to move this negative 4x over here to the left side. That'll keep everything positive. So I'm going to add 4x, okay, add 4x, and then that's going to give me 0 on that side, 12x here, 8x plus 4x is 12x, and that's going to equal 24, okay? And now what I want to do, I have a one-step equation. I'm just going to divide by 12 on both sides, okay, and I'm going to get that x is equal to 2, all right? And we can check our answer, but you know, that's how we do something like that. So that's what you do when you see a number on the outside of parentheses like that. So let's go ahead and do another one of these. Now this one's going to involve a few more of these because I notice I have 2 of them. So I have 2 minus 5 times the quantity, x plus 5, and that's equal to 3 times the quantity, x minus 2, and then minus 1. So what I want to do is I want to distribute this negative 5, okay? And I'm going to distribute the negative as well. So my first step is going to look like this. 2 minus 5 times x minus 5 times 5. Okay, and I could put a plus in here, a plus negative, to kind of get the signs right. And this is kind of where, you know, we have a tendency to make mistakes. And it happens to me all the time. Okay, and most of my mistakes, guys, that I make are just error signs, or I write down the wrong number. Okay, so, you know, just be careful. All right, next side of the equal sign, I want to distribute my 3. So I've got 3 times x and then 3 times negative 2. So I'm going to do 3 times x, and then I'm going to do this. I'm going to do plus 3 times negative 2. I'm going to put that in parentheses. Okay, it never hurts to put these numbers inside of parentheses, okay? And then we're going to subtract 1. All right, so let's do the math here. I've got 2 minus 5 times x, and then negative 5 plus 5 gives me minus 25. And then this is going to equal 3x. 3 times negative 2 is going to give me minus 6, and then minus 1. All right, so what I can do at this point is I can now combine like terms. So I have a 2 minus 25. That's going to give me negative 23. So I've got negative 23 minus 5x is going to equal 3x, and then negative 7 minus 1 is going to give me, or I'm sorry, negative 6 minus 1 is negative 7. Okay? And so now what I want to do is I want to get all my x's on one side, all my numbers on the other, and so I'm going to do this. Okay? I'm going to go ahead and add 5x to both sides. Okay, add 5x, add 5x. So negative 5x plus 5x adds to 0. And we get negative 23 is equal to 8x minus 7. Okay, now I want to add 7 to the other side. Okay, and that's going to give me, I'm going to do plus 7, plus 7. Okay, these add to 0, and then we're going to get 8x on the right side. And then we're going to get negative 16 on the left. Negative 23 plus 7 gives me negative 16. And then we're going to divide both sides by 8, okay, just like so. Then we're going to get negative 2 is equal to x, okay. And that's the same thing as me writing x equals negative 2. It doesn't matter. I can write it either way. All right, so a lot of steps, guys. This is where it gets tricky, okay. But if you just be calm and do what you're supposed to do, and just ask yourself the question, you know, going through this, you know, what did he do from this step to this step to this step? And just keep asking those questions. And that's what you have to do in your head. Like, what do I do next? What do I do next? Okay, what can I do? And, you know, you can move things around. You know, you can kind of play with it. And there's, you know, this isn't the only way to do this problem. Okay, I could do this a number of ways. You know, after the first step, once I get to this step, I really can kind of do whatever I want, as long as you follow those rules. If you do something to one side, you have to do it to the other, and vice versa. Okay. All right. Let's talk about types of solutions. So we're going to run into this issue where we're going to solve an equation, and something's going to happen, and things are going to be really jacked up. Okay. So the first thing I want to do is I want to take the 7 and I want to distribute it to the x and to the negative 3. So then I'm going to get 7x minus 17 is equal to 4. And then, okay, we've got plus 7 times x plus 7 times negative 3. Okay, and so now what I want to do is I'm going to get 7x minus 17 is equal to 4 plus 7x minus 21. Negative 3 times 7 is negative 21. Okay, and then I want to combine my like terms. I have the 4 and the negative 21, and so on the left side, we're going to keep writing what we write down. Just don't change anything. We're not doing anything. And then I got 7x, and then 4 plus negative 21 is going to give me negative 17. And I want you to notice something. Notice how the left side is the same as the right side. And so if I did this, if I got all my x's on one side, so if I subtract 7x from my right side over to my left, this is going to add to 0, and this is going to add to 0. Wait a second. So all of a sudden, my x's are gone, okay? And what I'm left with is I'm left with negative 17 is equal to negative 17. And these numbers are the same, okay? This is a true statement. And what that means is that any number I plug in for x here will give me a true answer, okay? So I can actually type in any value for x, and it'll come out with a true statement in the end, okay? So what I'm going to write here is that when you get a true statement, what this means is that you have an infinite number of solutions. Okay? And that's what we've got. So these are special cases. So this might happen where you get, your x's cancel out, you don't have any variables anymore, and you get a true statement. That means you have infinite solutions. Okay? Let's look at one where you're going to have no solution. Okay? So let me do this. Let me go ahead and solve this equation. Let me distribute my 4 here. So I get 3x plus 4 times x plus 4 times 2, and that's equal to 11 plus 7x. Okay? And so if I combine my like terms here, 3x and 4x, that's going to give me 7x. 4 times 2 is going to give me plus 8, and that's going to equal 11 plus 7x. Okay, let's combine all my variables. So I'm going to move this 7x over to the left side. So I'm going to subtract 7x from both sides. Okay, that's going to cancel out, and wait a second, these are going to cancel out. But look what we're left with. Okay, 8 is equal to 11. These are different. Okay, this is a false statement. 8 is not equal to 11. So that means that we have no solution. Okay, and if I do no sol, that means no solution. Okay, it's abbreviation. Okay, so now let's think about this for a second. Okay, I want to look at this step here and this step here. Okay, if I were to say, and come over here and do like, and let me rewrite this down. 7x minus 17 is equal to 7x minus 17. Not only do I have the same thing on the left side and the right side, let's do this. Let's just let x equal some number, okay? Let's let like x equal 2, okay? We could let x equal anything we want to, okay, at this point. So what I want to do is this. I want to do 7 times 2 minus 17, 7 times 2 minus 17 here. Put an equal sign in between. Okay, and what I would do is I would say, okay, what's 7 times 2? That's 14. Okay, minus 17. Okay, same thing on this side. I've got 7 times 2, which is 14, minus 17. And what I'm going to get as a result, 14 minus 17, is negative 3. Okay, and that's also going to give me negative 3, which is a true statement. Now, the other thing I can do is I could say, all right, and you can just kind of look at this. Let's let x equal 3. Okay? Let me do 7 times 3 minus 17. 7 times 3 minus 17. Okay? When I do that, I'm going to get 21 here minus 17 is equal to 21 minus 17. All right, 21 minus 17 is going to give me positive 4, and 21 minus 17 is going to give me positive 4 as well. So this is a true statement. And so what I notice about this is that no matter what I plug in to this equation, I'm going to get a true statement. Okay? And that's the idea. That's why it means infinite solutions. All right. If I come over here, and let's look at this step here of 7x plus 8 equals 11 plus 7x. So let's let like x equal, I don't know, 2. All right. If I do 7 times 2 plus 8, is that going to equal 11 plus 7 times 2? All right, 7 times 2 is 14, so I've got 14 plus 8 is equal to 11 plus 14. Okay, 14 plus 8 is going to give me 22. All right, if I do 11 plus 14, that's going to give me 25. This is a false statement, okay? X equals 2 doesn't work. Okay, let's try x equals 1. Okay, let's do that. Let's let x equal 1. Okay, and if I do 7 times 1 plus 8 is equal to 11 plus 7 times 1. 7 times 1 is 7 plus 8. Is that going to equal 11 plus 7? Okay, and the answer is no. Okay, 7 plus 8 is going to give me 15. 11 plus 7 is going to give me 18. And this is false. So it doesn't matter what I plug into this equation, I'm not going to come up with a correct answer. I'm not going to have a solution that makes this true. Okay? So this is a pretty big section, guys. There's a lot going on here. You know, take your time with this. This is where, you know, this is the skill that you know, you're going to need to be able to do moving forward, is solving an equation. And you know, and operating with positive and negative numbers too. You know, that's a big part of this. So you have to, if you're really struggling with opposite and negative numbers, adding them, subtracting, multiplying, dividing, that's something we really need to practice with. Okay, and then as much practice as you can with this. So here's your homework. I know it's a long video, I apologize, but you know, if you got any questions, you know, give me a shout. I'm sure you will. So good luck, and we'll see you soon. Thanks a lot. Bye.